Hello everyone, in this session we will discuss how to achieve Retrieval-Augmented Generation, that is RAG, using only Keras NLP package. If you are not familiar with RAG, that is Retrieval-Augmented Generation, please click on the link in the top right corner of this video where I have explained RAG in detail. Now let's deep dive into the script to understand how to implement RAG using Keras NLP. In this script, you can see that we have used only two packages. One is NumPy and another one is Keras NLP. So over here, we are not using any third-party packages for storing vector embeddings or retrieving relevant documents. The package versions are displayed on the screen. Also note that I am running Python 3.11 in Docker instance, since the Keras NLP package does not work with Python 3.12 on Ubuntu. In this script, first we will import the required packages. Next, we will load the preset model for the respective task. Notice that for the first model, we are not using the built-in preprocessor, since we will be using a custom preprocessor to generate the text. In the second model, we are using built-in preprocessor, and hence I haven't mentioned it over here. It is important to note that we will be generating the text in two different ways. One is using model 1 and another one is using model 2. Next, we have defined number of sentences as our raw data. I have provided a list of sentences that we will be using to retrieve the answers. This is the getEmbeddings function, which will generate embeddings using the backbone function of the selected model. The next function is cosine similarity function. This function will calculate the cosine similarity score, which help us to find the most relevant documents or text or sentences for the given query. Following that, we have document retrieval function. This function utilizes the previously defined functions. First, it will generate vector embeddings of the query using getEmbeddings function, and then it will compare query's embeddings with the raw data embeddings using the cosine similarity function to find the best matching sentences. Next, we will move on to the answer generation function. So this is the function generate answer. Here we retrieve the relevant sentences for the given query, and as mentioned earlier, we will use two different methods to generate the answer. In this input text, we will provide the context. So this context will be the retrieved documents, which we will provide to the LLM to get the relevant answer for the given query. The question will be the query that we have asked, and over here answer, we will expect that LLM provides some answer based on the retrieved documents. In this first method, we will use a custom preprocessor where we will input both the query and the retrieved documents to generate token IDs. Then we will feed these generated token IDs into the model's generate function to generate new token IDs, and then these newly generated token IDs will be de-tokenized to generate human readable answer. In the second method, we will provide query and its relative documents or sentences directly to the generate function of the model without any token IDs. And from this provided text, the model will generate human readable text directly. Here is the dictionary that we have defined to store vector embeddings. Of course, if required, we can write these embeddings to a local file as well. And finally, I am generating the answer for the given query using two different methods. That's it for the day. Thank you everyone for watching this video.